Okay, so today we're going to talk about trig functions. Now this is based upon our wrapping functions. So let's start with here in the very beginning. This is saying what's the wrapping function of pi over 6? Well, if you remember, if we just draw a real quick unit circle here, pi over 6 is in this location right here. So what are the coordinates of pi over 6? Well, they are root 3 over 2, comma, 1/2. So based upon that, what would be the sign of pi over 6? Well, the first thing we have to talk about are what's a radian. We went through already talking about how if that's a location, I could then draw a triangle. Then we talked about this angle measure. Well, you can talk about any location on a circle using two things. One is with an angle measure, just like we would do here, this angle measure right here. Okay, if this was 30 degrees or 40 degrees or whatever. Okay, but we can also talk about in terms of radians. And what a radian is the measure or the distance from this location along the arc up to that spot right there. So if that's pi over 6, that means the distance, if I were literally to measure from here to here, okay, the distance would be pi over 6 units long. So let's pretend like that's an inch. The radius is an inch for this circle. If this was pi over 6, then that would be about a half an inch long right there, because pi is like 3 over 6 as a half. So if I'm asking you to find the sine of pi over 6, okay, let's draw a little bit bigger circle here. Okay, so here's pi over 6. Well, what do we know? We know that this is 1. We know that this right here is root 3 over 2. And we know that this is half. So the sine of pi over 6 is opposite over hypotenuse. Well, that is, in this case, opposite was a half over 1, which is a half. If I want to know what the cosine of pi over 6 is, cosine would be adjacent over hypotenuse, which is just root 3 over 2. And we'll come back to tangent here in just a second. But let's do the same thing here, though, but with pi over 4. So if I draw unit circle again, excuse me, sorry. If I draw another unit circle, pi over 4 is in this location. Coordinates are root 2 over 2, comma root 2 over 2. So if I were to draw my triangle again, I know that's 1, I know that's root 2 over 2, and this is root 2 over 2. So if I were going to ask you what's the sine of pi over 4, that's opposite over hypotenuse, over 1, which is root 2 over 2. Or cosine is adjacent over hypotenuse, which is just that. Well, what do you notice about these answers and the coordinates of these spots on the unit circle? Well, hopefully one thing that you've noticed is that when I did sine of pi over 6 equals a half, that's the same thing as the y-coordinate. And when I did cosine of pi over 6, I got root 3 over 2, which happens to be the x-coordinate. And that is true, and that's one of, that's a generality that we are going to make. And that is, if I have cosine of theta, okay, that equals adjacent over hypotenuse. So in the unit circle, okay, if we were to just create a triangle here, it doesn't really make a difference right now. If I were to call this the radius, this x and this y, it's equal to x over r. Well, since the radius of the unit circle is 1, that means it's x over 1. So in other words, it's x. So it's the x-coordinate of the wrapping function. And so if I were to do the same thing for sine of theta is opposite over hypotenuse. So that's y over r, which is y over 1, because the radius is 1, which is y. Okay, and that's why we are learning all these wrapping functions. When I say what is pi over 3, or what's the wrapping function for pi over 3, and you tell me it's 1/2 root 3 over 2, what you're really telling me is that you know what the cosine of pi over 3 is, which would be 1/2, and the sine of pi over 3 is root 3 over 2. Now, we can do this same thing with all the other functions as well, and that is if we talk about tangent. Okay, tangent of theta, okay, is opposite over adjacent. Well, y is the same thing as sine. X is the same thing as cosine. So when we talk about tangent, tangent is sine over cosine. If I were to do tangent of 30 degrees, it would be the same thing as if I were to do the sine of 30 and divide it by the cosine of 30. It works out identical. Okay? Now, like everything else we've done, the reciprocal functions all work the same way as well. So if we were to do secant of theta, that would just be 1 over cosine, as we know, which therefore that means it's 1 over x. If I were to do cosecant of theta, that'd be 1 over sine, which is 1 over y. And if I were to do cotangent of theta, that'd be 1 over tan, or tangent, or cosine over sine, or x over y. And they all mean the exact same thing. So what does that mean? Well, we're going to go through and do a bunch of practice problems here, but we're going to do some basic ones here, and then we'll try a little bit more difficult ones. So keep that in mind right there. So let's do these here. So for instance, I actually want to do one even before any of these. Let's just do something like this. We'll call it 1a, if you will. What if I said, what is the cosine of 7 pi over 6? So what we're doing is, one is you got to keep in mind, write it down or in your head, that the coordinates of 7 pi over 6, now that's down here in this quadrant. Whoops, sorry. That's down here in this quadrant. So that means it's negative root 3 over 2, comma, negative 1/2. So the cosine of 7 pi over 6 is going to be the x-coordinate, so negative root 3 over 2. That's it. As simple as that. If I were to ask you the sine of 7 pi over 6, you would tell me it's negative 1/2. Well, let's do one that I have written over here. What about the secant of pi over 3? Well, the coordinates for pi over 3 are 1/2 root 3 over 2. The secant, remember, is 1 over cosine. So that'd be 1 over x. So 1 divided by 1/2, which is 2. That's it. That's all there is to it. So this is why you need to really know all those coordinates of all those locations. Let's try another one. Let's try cotangent. Let's move it over here so we have a little room. Well, again, we know cotangent of pi over 3. We know the coordinates are 1/2, comma, root 3 over 2. So cotangent is x over y. So it's 1/2 divided by root 3 over 2. Now that's not the prettiest, but once I were to divide 1/2 divided by root 3 over 2, you flip it over and you end up getting root 3 over 3. Okay, if you don't understand how I did that, just go ahead and divide it up, and I promise you'll end up there. What about the sine of 2 pi over 3? Well, the coordinates for 2 pi over 3 are negative 1/2 root 3 over 2. So the sine of 2 pi over 3 would just be root 3 over 2. That's it. Well, tangent of 7 pi over 2. Well, tangent of 7 pi over 2, well, 7 pi over 2, remember, is 3.5 pi. So in terms of the unit circle, that means we're going 1 pi, 2 pi, 3, and then we're going 1/2. So we're sitting down here. So the coordinates for that are 0, -1. Now tangent, remember, is sine over cosine, or y over x, which we all know you can't have 0 on the bottom, so that's undefined. Okay, so these trig functions right here are, first, just an exercise in, do I know my coordinates? And second, what are we asking for? If I'm asking for sine, I'm just asking for what's the y coordinate. If I'm asking for cosine, it's just the x coordinate. If I'm asking for secant, 1 over x, etc., etc. Now, if you know all those things, then you can start simplifying things like this. It looks kind of complicated, but in reality it's not. If it says cosine of pi over 2, well, that's asking what's the x coordinate of pi over 2? Well, that's 0. Sine of pi over 3, well, pi over 3 is 1/2 comma root 3 over 2, so that's root 3 over 2 minus cosine of pi over 3. Again, pi over 3, the coordinates are 1/2 comma root 3 over 2, so that would be 1/2. And sine of pi over 2, that would be, the coordinates are 0, 1, so sine would be 1. Well, this obviously cancels, and we just end up with -1/2. And obviously we can do more complicated ones than that, but what we're learning here is just basically kind of a stepping stone. We're learning how to come up with these values without having to use calculators, etc., etc. But again, it all comes back to that unit circle. Do I know all the coordinates of the unit circle? So hopefully that makes sense. If it doesn't, feel free to ask when you get into class. Thank you.